could be a function. If I set it equal to y, it would be a function. Do you remember when we solve things, we kind of set them equal to 0 anyway, and we get, what that really means is that we've moved all the terms to one side. So one of the things with synthetic division problems, I don't think they're going to give any to you that aren't everything on one side, but you want to move them on one side, and you want to put them in what we called standard form. And of course your book probably uses a different term, but we always write the largest exponent first, and then we just keep going down, one exponent at a time. And if there's anything missing, we want to fill it in with a 0 in front of that x with that exponent on it. So let's just check really quickly here. I think we've got all the terms. There's an x to the 4th, then there's a cube term, a square term, to the first power, a linear term, there's that, and then there's our constant. So we were not missing any terms here. It's not like we had 6x to the 4th plus 3, where all the cube, square, x terms were missing. So we want to make sure we put them all in there, otherwise we're not going to get a good result out of this. So what we're doing when we divide by x plus 2, remember this would be the factor. They write this as x minus k, and where you're dividing by k, your number that you're going to divide for when you do synthetic division is your k there. What would my k be here? It's like my 0. What would my 0 be of this factor? My solution if I said x plus 2 equal to 0. If I thought, minus 2. You think of this as like it's a factor. And we're going to divide by x plus 2, but we're going to just use if you remember synthetic division, what we do is we just use the coefficients off each term, the numbers in front, and we divide by the 0. So you might think we divide by 2 here, but it's minus 2. It's whatever the 0 is. So we're dividing by the 0. Okay. So I'm going to put minus 2 out here, and if you remember with synthetic division, we kind of do this upside down division sign, and we're going to pick off all of our coefficients here, and we need one for each term. That's why I said put a 0 in for a term if it's missing. So it's going to be 1, and then 5, and then 6, and remember that would be a negative 1. Just lazy math guy doesn't write ones, right? And then a minus 2. And I'm leaving space underneath it, because if you remember with synthetic division, we're going to be doing some squirrely things here. We're going to be mostly adding. We could do long division here. Oh, it did say use long division to divide, so I'm using the wrong instructions, but we'll go ahead and do this as an example and count this one. We'll do another one with long division, okay? You can do it either way. Either way gives us the same result. Okay, so if you remember with synthetic division, once you write those numbers down, you have to have something to get you started, so you always drop down that first number here. And then you multiply by this number out front, anything that's down here on the bottom. Negative 2 times 1 is negative 2. Write it underneath the next number. That's supposed to be a minus 2, and it looks funky. And then I add together. What's 5 plus minus 2? 5 minus 2 is 3. Then I say negative 2 times 3 is negative 6. I write that result right up here, above that division sign, and I add those two things together. 6 plus negative 6 is 0. Okay. Now, every time I get a new number down here, remember, I go back and I multiply it by the thing, that negative 2 that's out front. Negative 2 times 0 is 0. Negative 1 plus 0 is negative 1, yep. And then negative 2 times negative 1 is 2, and negative 2 and 2 is 0. Now, this is good that I have a 0 there, because if you remember, that 0 there means it went in evenly. This would be my remainder. If I have a remainder of 0, it means that it went in evenly. So this one divided evenly. This one divided evenly. Okay, so what I'm doing now is, if I kept going with this, here would be my result. They didn't ask me to keep going with this one. They just said divide it by x plus 2, which is what I'm doing. It just looks a little weird right now. Do you remember that when I go back to say what my remainder, what was x plus 2 divided into this big thing, I have to go back and stick my x's back in, because I did not take all of them out just to do this quickly. If I started with an x to the 4th, but I divided out at x plus 2, and x to the 4th divided by x would mean the biggest thing I'd have left would be an x cubed. You always go one down from the exponent you had when you started. So this 1 would be a 1 x cubed. The 3, you just keep going down with your exponents. That would be 3x squared. I'm going to go ahead and put plus 0x, and then minus 1. I got to make sure that I'm just counting down 1 by the exponent every time as I put those numbers back in front. So far, is any of it sounding familiar? Just relief a long time ago, isn't it? So you have to kind of get in the swing of this again. I wouldn't really write this. Ben?
Is the -2 still go with it?
Well, what this -2 really was an x plus 2. This was the 0 that I got from this. So I could look at it this way. This expression up here is x plus 2 times all this that I rewrote down here. And I would probably just write, x cubed plus 3x squared minus 1. I wouldn't put the 0x in it. So if I want to look at it this way, this times x plus 2 would give me back what I started with. X squared minus x minus 2, that whole long expression is equal to those two things. And what I usually try to do is keep factoring with it if I can. It might not work, but we try to get it down. If you remember, what you're always trying to do is to break things down into these either linear factors, which means like an x plus 2 or an x minus 1 or something like that, or if we could get it down to an x squared factor, then all kinds of loveliness can happen, like the quadratic formula or taking square roots, or factoring if it factors. You're always just trying to keep, the goal here is to break it down into its little pieces so we can solve it. And sometimes we look at things and there's just no easy way to go factor what we started with. So you can leave that for your number 3. You don't have to redo number 3 since I did it with synthetic division. Let's do one with long division, because I just jumped ahead on the synthetic division here, and it actually said we were supposed to do long division. Let's pick number 7 just because it's also missing a lot of stuff. Oh, no. Yeah, let's pick 7. Okay. So it says divide 7x cubed plus 3 by x plus 2. And again, if I don't write in all those missing terms, I'm probably going to have a mess when I get done, especially with both of them. It doesn't really matter. If I'm doing long division, I'm not thinking about the zeros. I'm just saying I'm going to take and I'm going to put x plus 2. I'm dividing by x plus 2, so that goes on the outside. And then I write this expression on the inside, but you know what I better do? I better put 0x squared plus 0x, because this gets awfully confusing. And then we have a 3, right? So I'd want to write it that way when I do my long division, or I'm going to get really confused in the middle of it and get lost. Okay, so if you remember, all we're doing is we're taking this term right here, the 7x cubed, and we don't think about the whole x plus 2. We only think about that first part of it, the x. How many times does x go into 7x cubed? Remember, you could think like this, 7x cubed divided by x, because isn't a fraction the same thing as division? Okay, so we could do it to help us think. If you need to, you could come off down here and to the side and do this little thing here. If I took an x out of 7x cubed, though, wouldn't I have a 7 and an x squared left? So let's see. Remember what we do is try to figure out how many times x goes into 7x cubed. That would be, again, the equivalent of coming down here and reducing this fraction. Now we're going to multiply it out times both terms. 7x squared times x would be 7x cubed. And then 7x squared times 2 would be 14x squared. Do you see why we needed that x squared term with a 0 in front of it now? When you do long division, do you remember that you always put it up there, whatever's up here. You say whatever's up here times whatever's out front, and you write it down like we just did, but then you have to subtract it, right? Remember how, if you ever get stuck on this, just pick like 13 divided by 5 or something and try to, go through it and say, okay, oh yeah, subtract once I get, once I multiply this out and get that I wrote in red down there. So what is 7x cubed minus 7x cubed? 0. Yay. Okay. That's what we need to have happen every time. What is 0x squared minus 14x squared? Negative 14x squared. Okay. I'm going to change colors every time I start a new division thing in the middle of this, just so maybe you can follow it if you're watching it later. Now I got to think, okay, do you remember also that what we do is we always bring down the next term to do, wouldn't I bring down 0x here? Think about what you do with long division. Just, again, go pick something and divide it out that doesn't go in evenly. You always bring down the next thing. How many times does x plus 2 go into negative 14x squared plus 0x? I'm really looking at this term and just saying how many times does x go into negative 14x squared? If I divided negative 14x squared, divided that x out, wouldn't it be minus 14x, right? Okay, so now I multiply it out like I did above. Negative 14x times x would be negative 14x squared, and negative 14x times 2 would be negative 28x. Right, don't I? So I'm going to go, okay, I got to subtract all of that. So negative 14 squared minus 14 squared becomes negative 14x squared plus 14x squared, which is 0, right? 0x minus 28x would be positive, wouldn't it? Because, yeah, so two negatives make a positive, so 28x. Okay, so now all I've got left to do is one more step. I need to bring down my 3. Okay. How many times does x go into 28x? 28 times, right? Okay, so it would be plus 28. 28 times x is 28x. 28 times 2 is 56. And once I write it down, I got to remember, oh yeah, I'm subtracting it. 28x minus 28x would be 0. 3 minus 56 would be what? Negative 53. That's my remainder right there. Haven't I brought down every term, you know, up from up there? Every time I got a result, I brought down the next term. So I've got a remainder of negative 53. How we write that, do you remember you could either put remainder negative 53, which is our favorite thing to do when we were in elementary school because we didn't have to make a fraction out of it. But what we do here is we say that's minus 53 over what we were dividing by, x plus 2. And that would be that one divided out using long division.